In this video, we will be solving rational equations such as these. There are many methods for solving rational equations. For example, I could cross multiply these, but in this video, I am going to use the method of making like denominators and canceling out the denominator. In the end, you should get the same answer no matter what method you use. So if I want these denominators to be the same, I'm going to look at this x minus 4 as a single factor, and I'm going to look at x minus 6 as a factor. So since the right hand side has an x minus 4, that means the left side will need an x minus 4. Now anything you put in the denominator, you have to also put in the numerator. Okay, so I put an x minus 4 in the numerator and the denominator. That way, I'm really just multiplying by 1, and I'm not changing anything. Since this side has a x minus 6, then this side will also need an x minus 6, which again, I will put in the numerator and the denominator. Once you have the denominators the same, then you can just set the numerators equal to each other. In other words, it would be like canceling out the like denominator. So now we have x minus 4 times x is equal to 1 times x minus 6. Alright, a little distributive property gives us x squared minus 4x is equal to x minus 6. So now there are no more fractions, so this should be pretty simple. We'll just get 0 on one side and possibly factor. So I will subtract x from both sides, and I will add 6 to both sides. That's going to give me x squared minus 5x plus 6 equals 0. Now this is probably factorable. X squared is x times x. 6 is either going to be 2 times 3 or 6 times 1. Let's try 2 times 3. We know that inner plus outer is equal to the middle. Inner, I have 2x. Outer, I have 3x. To make negative 5, both of these would need to be negative. And a negative times a negative will give us the positive 6 that we need as well. Okay, so now that this is factored, I can set these equal to 0 in order to solve. That's your zero product property. So that gives us x equals 2 or x equals 3. So these are the two answers. Well, we have to be careful and just make sure that none of these values are extraneous or illegal in the sense that you can't divide by 0. So for example, looking right here, we know that x cannot equal 6, alright, because if x were 6, 6 minus 6 is 0. And looking at this denominator, we know that x cannot equal 4. So those are the excluded values. So let's just make sure. Now, neither of these are excluded, so we're good. Okay, let's do another example. Again, I'm going to do this by the like denominator method. So if I sort of look at this as a fraction, now this denominator is n plus 4. So I need this denominator to also be n plus 4. But whatever I put, I need to put the same thing in the numerator and the denominator. So I've got n plus 4 in the top and the bottom. But now I have like denominators. So if the denominators are the same, then the numerators must be equal. So that means that 4 must equal n plus 4. Okay, in other words, it's similar to, it's the same thing you would get if you canceled out the denominators. So if I were to subtract 4 from both sides at this point, that would give me 0 is equal to n. And that would be the answer. Okay, I'm doing a quick check to make sure that 0 is not one of the excluded values. Looking at this denominator, I can see that n cannot equal -4. Alright, I'm getting these excluded values by setting the denominator equal to 0. Alright, I know that n plus 4, the denominator, cannot equal 0. Subtracting 4 from both sides gives me n cannot equal -4. That's where I'm getting this from. Alright, but I usually do that in my head. Alright, let's look at another one. We need like denominators. Okay, this has a 4y and this has a 6. The 4 and the 6 can both be turned into the number 12. They can be turned into bigger numbers as well, like 24, for example. But 12 is the smallest, so I'm going to turn both of these into 12s. Also, I see a y here, so they both need a y. So since the left side has a y, that means the right-hand side will need a y. Any changes I make, I need to put it in the numerator and the denominator. So y in the numerator and y in the denominator. Now I need to make these both into 12s. But the way I will do that, to make this into a 12, I would have to multiply by 3. To make so if I do that on the bottom, I need to do that in the top as well. To make this into a 12, I need to multiply by 2. So I'll multiply by 2 in the top and the bottom. Okay, now that gives me like denominators. I sometimes will skip this step, but I'm going to show it this time just to make sure that everyone is really clear on what's happening. So in the numerator, I have 3 and 2y minus 1, okay, over 12y. And in the other fraction, I have 8y. Well, you know what? I'm just going to leave it separate just for another second. Okay, I have 2 times 4y over 12y. Okay, so you see how the denominators are the same? So if the denominators are the same, then the numerators must be the same. So I can set 3 times 2y minus 1 equal to 2 times 4y. It's as though I crossed out the denominators. Okay, now when you get comfortable with this, you'll start doing some of these steps in your head. You don't have to show every single step the way I'm doing. Now I'm going to do the distributive property, so this is going to be 6y minus 3 is equal to 8y. I think I will subtract 6y from both sides. Next. So that'll give me -3 is equal to 2y. Then I can divide both sides by 2. Alright, and that's going to give me -3 over 2 is equal to y. And that is the final answer, as long as it is not an excluded value. So looking back to the beginning, I see I have 4y in the denominator. So that tells me that y cannot equal 0. And again, I'm getting that by setting 4y equal to 0. Alright, the denominator cannot equal 0, so 4y cannot equal 0. If I divide by 4 on both sides, that gives me that y cannot equal 0. So that's my excluded value. So this is fine. Okay, let's do another one. So looking at number 4, I'm going to look at x plus 2 as a single factor. So let's see, the left side has a 4. So that means the right denominator is going to need a 4 as well. So I will put that in the top and the bottom. Okay, now you know what, I feel like I need to just spread this out to make this easier to follow. So that's what I'm going to do. I'm just going to space this problem out a bit. So this problem, I have 3 over 4x, and now I'm just making space, and this is equal to 5 over x plus 2. So this is just the same problem that I had, but now I have more space. Okay, so I see I have an x plus 2 on the right hand side. So I know I'm going to need an x plus 2 on the left. Okay, so I'm going to put an x plus 2 in the top and the bottom. So now they both have that. Now the left side has a 4 and an x. It has a 4x. So I'm going to do 4x in the bottom and the top. Okay, now I have like denominators. If the denominators are the same, I can now set the numerators equal to each other. So that means 3 times x plus 2 will equal 4x times 5. Okay, it's as if you are canceling out the denominators, but it's really just logic. You know, if I have a over b is equal to c over b, if I know that the denominators are the same, the only way these fractions will be equal is if the numerators are also the same. Alright, that's just common sense. Anyway, I'll keep going. So distributive property, so that'll be 3x plus 6 is equal to 20x. So now I will subtract 3x from both sides. And that's going to give me 6 is equal to 17x. And then I will divide both sides by 17. And that's going to give me my final answer. So 6/17 is equal to x. Okay, and we'll just make sure that that's not extraneous. The two excluded values would be, because of the 4x, I know that x cannot equal 0. And because of the x plus 2, I know that x cannot equal -2. So those are my restrictions. Okay, but this is not any of those, so I'm fine. Okay, let's see how many. Let's do 2 more problems on this video, and then I'll put the rest on another video. Okay, so again, I'm going to look at this as a fraction, and I think I'll spread it out again. That worked out pretty well last time. So I have x minus 2 over x plus 2. I'm going to leave some space, and this is equal to 3. But I'm going to go ahead and write it as 3 over 1 to make it easier to see what I'm doing. Okay, so on the left side I have x plus 2. That means I'm going to need x plus 2 on the right as well. But anything I put in the bottom, I need to put in the top. Alright, and that's really it. My denominators are the same. So since my denominators are equal, I can go ahead and set the numerators equal to each other. So that means x minus 2 is equal to 3 times x plus 2. Alright, it's just like crossing out the denominators, the like denominators. So that's going to give me x minus 2 is equal to 3x plus 6. Okay. If I were to subtract x from both sides to get the x's together, now I could have subtracted 3x from both sides, but I just like the x's to be positive, so I subtracted x, so this will be positive, but it doesn't really matter. So I'm going to get negative 2 is equal to 2x plus 6. And now I'm going to subtract 6 from both sides. Alright, so I'm going to end up with a negative anyway. So I have negative 8 is equal to 2x. And then I'll divide both sides by 2. So that's going to give me negative 4 is equal to x. And this is the answer as long as it is not one of the restricted values. Okay, so looking back, the only restricted value would be that x cannot equal negative 2. Okay, and of course we get that from setting this equal to 0. Alright, let's do one more problem. Okay, it looks like we're going to have to do some factoring. So when you see 2p minus 4, I hope you're thinking about what the first step of factoring is. And that is to factor out the GCF, or greatest common factor. Alright, if you don't do that, it's going to mess you up. So I'm going to pull out that 2. Okay, now in the denominator, I'm going to factor this as well. Okay, so I've got p times p. 16 could be 4 times 4, but that's not looking promising. How about 2 times 8? Alright, remember, inner plus outer must equal the middle. Inner, I have 2p. Outer, I have 8p. To get a negative 10, both of these would have to be negative. So negative and a negative. And a negative times negative is a positive, so that gives us positive 16 that we wanted. So that's good. Okay, and now you can see the reason why I was careful to factor the GCF in the numerator. Because I can now see that there's a factor in the numerator and the denominator, p minus 2. So those are going to cancel out before we even begin. So if you cancel those out. Now, you know what? Before we do that, though, now would be a good time to say the restrictions. So look at these 3 factors in the denominator. If I set this equal to 0, I'm going to know that p cannot equal 2. If I set p minus 8 equal to 0 and solve, that tells me that p cannot equal 8. And if I set p plus 2 equal to 0 and solve, that tells me that p cannot equal negative 2. So these are the excluded values, or restrictions. So watch out for that. Make sure that none of your answers turn out to be any of these. Okay, so now that we've written that down, we can cancel out the p minus 2 factor. So that's going to give us 2 over p minus 8 is equal to 2 over p plus 2. So we want these to be the same denominator, so I'm going to give this a p plus 2 to be like its brother. I'll have to put it in the top and the bottom, the numerator and the denominator. I'm going to give this denominator a p minus 8 to match the one on the left. And again, I will do that in the numerator and the denominator. And I don't know why I just wrote a 2. Okay, now that the denominators are the same, all right, p plus 2 and p minus 8, that means the numerators must be the same. All right, so I can set these numerators equal to each other. So I have 2 times p plus 2. All right, that numerator should equal 2 times p minus 8. Okay, it's just like canceling out the denominators once you have like denominators. Now I could distribute the 2 and go on with the problem, and there's nothing wrong with that. But it would be clever, I'm noticing that I have 2 on both sides, so I could divide both sides by 2 right from the start, and then that would just give me p plus 2 is equal to p minus 8. You know what? This is going to be undefined, because I can tell if I subtract p from both sides right now, minus p, both of these cancel out. And that's going to give me 2 is equal to negative 8. When all the variables cancel out and you just have a number equal to a number, if you get a true statement like 2 equals 2, then that's when you say all real numbers. This would mean there are infinitely many solutions. But when you get a false statement like this, like 2 equals negative 8, which is not true, 2 does not equal negative 8, then that tells you that there is no solution. Okay, so this problem is going to have no solution. Okay, now I'm going to actually go back because I have a feeling many of you wouldn't have thought to divide the 2's away. So I'm going to go ahead and do what you probably would have done and distribute. So then you would have had 2p minus 4 is equal to 2p minus 16. And then you would have subtracted 2p from both sides, hopefully, to get those p's together. But again, all the p's cancel out. So that would give you negative 4 is equal to negative 16. Well, again, negative 4 does not equal negative 16. This is a false statement. So that means there is no solution. Okay, a little bit strange. All right, that's the last problem on this page. And this video is already 22 minutes long, so that's long enough for one video. All right, more problems to come in part 2.